Okay, and so today we are going to do the xy factor and simplifying expressions. Okay, so here again we're asked to simplify 2 by 3x minus 2y minus 4 plus 3 multiplied by 7x plus 5y minus 11. So simplify or expand sometimes is the word often used, and that's basically just to rewrite this without any brackets. Now the first thing that we know is multiplication, so any number outside the brackets, multiplication has a distributive property, which means this 2 is distributed over all the terms inside the bracket, and this 3, the multiplication aspect of it, is distributed over each of these 3 terms as well. So just rewriting very quickly, we have 2 bracket 3x minus 2y minus 4, and we'll close that bracket, and we have plus 3, again bracket 7x plus 5y minus 11, and again we'll close that bracket. And so the next job now is to multiply essentially this 2 by this 3, the 2 by the minus 2, and the 2 by the minus 4. And similarly with the 3, that the 3 gets multiplied by the 7, but it also is multiplied by the 5 and also by the minus 11. So multiplying those out, well, I have 2 by my 3x, I have my 2 by my minus 2y here, I also have my 2 by my minus 4 here, my 3 by my 7, my 3 by my plus 5y, and my 3 by my minus 11 right here. So, well, 2 multiplied by 3x, well, that gives us 6x. 2 by minus 2y, well, 2 by 2y gives us 4y. And then our major rule then for this moment, the plus by a minus, well, a positive by a negative gives us a negative. Similarly here, we have 2 by 4, well, that gives us 8, and a positive by a negative gives us a negative. Then similarly here, I have 3 by 7x, 2 positives, so that's a positive, and 3 multiplied by 7 is 21, so it's 21x. Next, then I have 3 plus 3 by 5y, so that's a positive, and 3 by 5 is 15, so 3 by 5y is 15y. Lastly then, I have a positive here by a negative, so I know that's going to be a negative straight away, and 3 multiplied by 11 is 33. So now the next most important thing here obviously is we put our like terms together. So here very clearly then I can see, well, I'll put my x's together, so that's 6x, my plus 21x, then my next terms then are my y's. So I'll have my minus 4y and my plus 15y. And then lastly just my numbers together. So that's the minus 8 and minus 33. And very important that we remember, the sign that is beside the number or the number and the letter, that number and letter, they own that sign. So anytime we reorder a maths expression, an algebraic expression, that sign has to travel with the term. So that minus travelled with that 8, that minus travelled with the 33, it travelled with the 4y, the positive travelled with the 21x. So they own that sign and it has to travel with them. And so lastly then, just tidying up, so 6x plus 21x, well that's 27x, minus 4y plus 15y, well that's different signs, so I'll subtract. So 15 take away 4, well that gives me 11y, and I keep the sign of the bigger number, which is the 15 in this case, so it's plus. And here then at the end I have minus 8 minus 33, so same signs add, so 8 and 33, well that's 41, and minus, I keep the sign, and that's my answer. So here we see in this example, or this question, we're asked to simplify, so simplify again, or to solve, or to expand 2x minus 3y multiplied by 5x minus 2y. So we have 2 brackets of 2 terms each, and we're asked to expand them. Now, very often we can be asked to do it in a specific model. So sometimes we could be asked to do it using the area method, where these might be the dimensions of a shape. maybe dimensions of a rectangle or something along those lines. So if we're asked to do it using the area method, very straightforward. It's very similar to as we would have done with integers. And we draw a box, and here we go again. So that's that part. And just before I label the box, I'm just going to rewrite. So I have 2x minus 3y in the first bracket, and that's multiplied by 5x minus 2y in the second bracket. So now I'm going to split each of the brackets down the middle. So just one term apiece for each quadrant of the table. Okay, so here I'm along the top quadrant, along this side, I'm going to write the first bracket. So here at this part I have the 2x, here I have the minus 3y, then down along the side I'm going to write the second bracket. So here I have 5x and here I have minus 2y. And again, we note the signs are travelling with the terms. Now, so this time, here in this first quadrant, well, what's multiplied by here for this rectangle? I have 2x multiplied by 5x. Well, I know that 2 by 5, well, that's 10, and x by x is x to the power of 2, or x squared. Over here then, in this quadrant here, well, I have 5x and minus 3y, so I'm going to multiply the two of them. So first of all, I see, well, it's a positive by a negative, so that's going to be a negative. 5 by 3, well, that's 15, and x by y is xy. The next one here that I have, well, I have, again, minus 2y is multiplied by the 2x, okay? So again, I have a positive by a negative, so that's a negative. 2 by 2, well, that's 4, and x by y is xy. Now, we're aware, aren't we, that order doesn't matter in multiplication. So xy, well, that's the same as yx. xy is equal to yx. But it's much easier for us if we just kind of go in alphabetical order. So while they're the same, while x is the same as xy, it's much easier for us to kind of put in alphabetical order first. Just in general. So x always comes before y in the alphabet. So that's the order I would write them. And then lastly, we'll just have a look at our last quadrant here. Well, I have minus 2y by minus 3y. So minus by minus, well, that's a plus. 2 by 3 is 6. And y by y is y to the power of 2, or y squared. Very simply then, we just want to tidy that up. And tidying that up, I just simply have, well, that all equals to 10x squared minus the 15xy minus 4xy and plus my 6y squared. And then lastly, just to tidy it up completely, I'm putting my like terms together. I have 10x squared minus 15xy minus 4xy. Well, how many xy is that? It's the same sign, so I'll add and I'll keep the sign. So that's a minus sign first of all. And 15 and 4, well, that gives me 19xy. And so here I have plus 6y squared. And that's my answer. Okay, so we're going to begin with this example, and we're going to use the normal method, the bracket method, to expand or to simplify these brackets. So as we'll see, always with these questions we'll be asked to simplify. So it's to make this sentence look a bit simpler or a bit easier. The other way we could be asked is to expand. So that means to work out both brackets. So the first thing that I'm going to do, I'm going to split that first bracket. And I know from before, when I've just worked with two terms in a bracket, that both those terms have to be multiplied by everything in the second bracket. So here I will have 3p bracket the 2p squared plus 4p minus 1. I'm going to close that bracket, and then I'm going to go back and look here at my second term in that first bracket, my minus 2, and again I'm going to multiply that by everything in the second bracket. So here I have my 2p squared plus 4p minus 1. And so tidying up that now onto the next line, I'm going to have 3p, well, that's bracket the first term in the second bracket there is 2p squared, And again, I have that 3p because it's getting multiplied by everything in this second bracket. And here, so I'm adding the 3p again and multiplying it by minus 1, the final term of the second bracket. Now we know, of course, that we're not done there. We have to still look after this second bracket here. So that minus 2 has to get multiplied by the 2p squared, by the 4p, and by the minus 1. So I'll have minus 2 bracket 2p squared, and the minus 2 again is going to be bracket our plus 4p, and again it's minus 2 bracket our minus 1. And so very simply now we're just going to tidy those up. So here in my first term over here, and just before I tidy those up again, it's good to count out how many terms I have. So here I have 1, 2, 3, 4, 5, 6, and here I'd have 1 and that one there, so that gives me 2, there, here, so I know I should have 6 because 2 multiplied by 3 terms gives me 6. So here, well, 3p multiplied by 2p squared, well, 3 by 2 we know is 6, and p squared multiplied by p, well, that gives me p to the power of 3 if we go back to our indices. Similarly here, I'm going to have this 3p multiplied by 4p, and I'm going to say, well, 3 by 4, and they're both plus, so that's a plus sign. 3 by 4 then is 12, and p by p is p squared. Here I have my 3p and it's multiplied by minus 1. So the first thing I see, I have a plus by a minus is a minus, and I have, so 1 by 3 or 3 by 1 is minus 3, and by p. Okay, so here then the next term I have minus 2 multiplied by 2p squared, so a minus by a plus is a minus. 2 by 2 is 4, so I have 4p squared. Here then again I have minus 2 by a plus, so that's going to be minus by plus is a minus. 2 by 4 is 8, and that's p. And my last term then, I have minus by a minus, which gives me a plus, and 2 multiplied by 1 gives me 2. So very quickly, just tidying up, I can see from the colours already that these two match together. So I'm going to rewrite my sentence now with those all beside each other. The like terms together are a big fundamental for maths, for algebra. Like terms beside each other or like terms together. So here I'll have plus 12p squared minus 4p squared. And here then the next set of ones that are alike, I have minus 3p minus 8p, and then out on its own, number 2. Okay, so just to tidy it up, well, 6p cubed, that's my only term with p cubed in it, so that's here together. Now I look again and I see I have 12p squared minus 4p squared. So my rule there, my DSS rule, different signs subtract and keep the sign of the bigger number. So 12 take away 4, that gives me 8p squared, and the bigger number there was the 12, so I'm going to keep the plus sign. Here then I have minus 3p minus 8p. Again, same signs, so I've SSA rule. So same signs, I add 3 and 8, well that gives me 11p, and I keep the sign, so that's the minus, and I have my plus 2. And that's our answer, as tidy as it can be. And so just before we finish up then, some basic rules for algebra. Obviously our most fundamental one is that we put like terms together. So our x's together, or our y's together, or our x squared together, and our a's together, whatever it is. Next then, same signs add, SSA, okay? So same signs add. What does that mean and why do we do it? Both of these, and also different signs subtract and keep the sign of the bigger number. Well, both of them come about just from our number line. So for example, I start off here, minus 1, minus 2, minus 3. And say for example, I'm starting off at minus 1 and I want to take away 2. Well, I know minus 1, if I take away 1 from that, I've a euro less, for example. If I take away another, I'm down to €3 less. But why is that? Why do I know it? Well, I know certainly if I was to be here, maybe, for example, at 1, and I added 1 to it, well, that would bring me to 2. So I know that if I'm adding a plus, that I'm moving in this direction, and if it's minus, I'm moving in this direction to the left. So here, if I have minus 1, minus 2, well, this minus 1, well, that's where I start. And the minus 2, that's the actual subtraction. So I need to move 2 spots to the left, 1, 2. So that's going to bring me to land me here. So that's why if it's same signs, I add 1 plus 2 gives me 3, but I keep the sign. Okay? And different signs subtract, well, it's the opposite operation. Okay? And then don't forget our rules for multiplication. So our rules for multiplication, 2 minuses, we multiply them together and we'll get a positive. A positive by a positive also gives me a positive. A positive by a negative is a negative, and a negative by a positive, well, that's a positive. Okay, there we go.